Hey, good evening, everybody. Shout out to Ryan on a little vacation. Pictures were beautiful. Hope you enjoy your time away. Uh, yeah, so another week has gone by. Uh, Episode 87, getting closer to that 100. Amazing. Hey, Rick, how you doing? I don't. You guys got a storm coming up your way, I think. Uh, yeah, so been busy this last week. Guys, I know Rick and Ryan follow on Facebook and stuff, so I had to rebuild the front end of my truck. Uh, the truck has been my truck has been pretty bad. Hey, Mike, how you doing? My truck has been driving pretty bad for a while, and I had all these control arms and everything in the garage in the house, and I was cleaning up out there, and I said, "Well, let me move these out to the shop." And okay, Rick, my Mike's weather guy showed a storm. It was covering most of the east, north, or from south to north, and running across. But anyway, yeah. So when I'm moving in the boxes, a receipt fell out, and I realized that I bought this stuff in 2023 because I saw that the control arm bushings were shot. Amazing how time flies. But yeah, so being we're going to be going up to Darlington, not this weekend, but the following weekend with the Cup car, I decided, with having the camper in the back of the truck and then hauling the race car and the enclosed trailer behind it, I better get the truck ready to make the trip and not have to worry about a ball joint popping or a tie rod or something crazy. And I found out the steering box was leaking, which I wasn't aware of, and it had gotten melted some rubber like on the anti-roll or the sway bar mounts and stuff like that. So it was well due. So I got that all done, and got it all, did the driveway alignment and got it up to Doug's up at DNR, and they let me use the machine. I went ahead and got a good alignment on it, and did a couple Holley EFI tunes this last week. So that's kind of made me think about wanting to show the what I found, and just to show how data logging can help you diagnose or tune a vehicle. So that'll be something we'll be doing here in a minute. Just get everybody caught up. I did get the 8100 built for Scott's Olnick race car hauler, and I hauled that up to DNR, so the engine and trans and all the bolt-on accessories and stuff is all up there. So I'm going to start doing that swap tomorrow. I'm thinking about maybe doing 2 to 3 days a week on it up there, being I'll be working out of their shop and outside. So this is like the last break of cool air, so I better make good use of it. Everybody in the shop, I guess Mike says, I guess now I should be inspired to do the front end on my Avalanche. Yeah, I tell you, when you seen the pictures, that was it needed it bad, and boy, does it drive sweet now. Hey, Chris, how you doing? So, yes, this weekend, Chuck and Dave and my buddy Mike and I all pitched in, and we got all the suspension back on Chuck's truck, and we have the brakes all hung and mounted. They don't have pads or brake lines or anything yet to it. That's our next go around, but at least now all the suspension is back together. We can get it down to the paint shop to get the firewall and the inner fenders and the core support painted, so it's ready for the engine install. And did a little work on Dave's Chevelle also, just doing a final on all the electrical on it. And I give you guys an honest thing here. My thought process on the dual window switches did not work. So Dave has a power window kit. Relic makes it out of North Carolina, and they actually put a switch in the door, and your window crank becomes the window switch. So you pull up on the crank handle, and the window goes up, and push down, it goes down. And then I put more conventional rocker switches on the center of the dash, and I figured I'd just piggyback onto the motor leads, and that would be fine. Well, it was getting feedback, and so once the car came back here, I said, all right, I'll go ahead and start figuring out where I went wrong with this thing. And my first thought was diodes. I got some really big, heavy-duty diodes, take a lot of amperage, and the diodes actually worked for the door switch. So with the diodes in at the rocker switches, the door switches would work. The rocker switches would still blow the fuse. I was going to build this diode trio thing. It was going to be a conglomerate, and I just wasn't settling with me well. I was worried that a diode may burn out down the road, and then we got service issues and stuff like that. So just out of whatever, I just decided, you know what, let me call Relic and see what those guys have done in the past. Sure enough, I got a hold of one of the techs. He answered the phone, and he kind of giggled. He goes, yeah, we've all ran into that same situation. We even here in their shop, when they were first building these kits, they ran into it. And so it's a ground feedback, obviously, because it's shorting the fuse. So, and that's why I knew, I was thinking diodes would break the direction of wiring current. But the guy's like, no, it's easier than that. Just unhook the grounds on our system, which goes straight to chassis ground, and hook your rocker switches to our grounds, and it'll use the ground feed through your rocker switches to our switch, and it'll work both directions, bi-directional that way. The rocker switch will work, and the switch on the door will work. And lo and behold, it worked. It fixed it. So, even I can overcomplicate things and get things messed up. So, just wanted to put that out there. And it's always a good thing. And sometimes I don't even listen to my own information, but sometimes you just have to call the manufacturer. Sometimes they do have good information, especially American built products with American ingenuity and stuff. If you got to call a company in China, you might not end up with the same good technical advice and stuff, but just wanted to throw that out there. So I wanted to show you, let me bring some pictures up here so we can get into the Holley stuff. Where did my pictures go? Let me gotta switch some stuff around here. Sorry about that. Thought I was a little bit more ready to go here. And I don't know how I only ended up getting one picture of Scott's. Obviously, I've got a whole build video, but I only got one picture of the engine. So let me bring this up. So here's Scott's engine, the 8.1 liter. We went ahead and, being we were putting it in a earlier Chevy truck, we decided to go back with orange rather than the corporate black. But yeah, it's all together, and it's up at Doug's, and we're getting ready to install that bad boy. It'll probably go in next week. Probably this week will be tearing it down. I'm gonna end up having to pull the entire front cap off. That some of the panels need to be blasted and rust repairs done, stuff like that. So I figured it'd just be easier to go ahead and pull the whole front cap off the truck, and that way I can get the motor and tranny out and put the new motor and tranny in using Doug's fork trucks. That should make it a lot easier to deal with. So that was one thing I wanted to show you. Wanted to show you Chuck's project, get you caught up where we're at with Chuck's. Let me fix some videos here, some pictures here. this thing's backwards. How's that? All right. So, show you some of the older pictures we had. So here's these are the frame bolting in some of the suspension joints where you had to drill holes and mount brackets and stuff. You had to take the leaf spring stuff off because it's going to be a 3-link when we're done. Had to C-notch the frame, which was a bolt-in kit also, which was really nice. We get through these pictures. We had then kind of crazy. I should have thought about this at first. I said, I thought we could scrape the frame, and Chuck and Dave kind of vetoed me and said, no, we need to roll this thing out and pressure clean it. So we hung the suspension back under it, got out on the driveway, and Chuck went nuts in there with the pressure cleaner. Just a couple pictures we took of that stuff. Didn't need to go that far back. So it looked pretty good after it started drying up. And then he went through and he painted the entire chassis with POR 15. I didn't realize I started back that far. These are all pre pictures. Here's some with the old brakes on the new front brakes. So here's the new front brakes all mounted up and everything, permanent. And the rears. So it's got 14-inch rotors front and back now, 6-piston calipers in the front, 4-piston in the rear. You can see the frame now is all painted up. Got the coilovers in and everything. So we only went with single adjustable because he's really not going to track the car. It's mainly just going to be show and cruise and stuff. There's that bracket for the trailing arm and frame painted, diagonal and stuff. So you can kind of see where we're going with it. Front suspension all back together now with the new spindles and all that. The tie rods are going to get a single adjuster there. Those haven't come in yet. And then just some pictures from underneath. Looks a lot nicer with the frame all painted. And that's the underside of the cab, which Chuck just washed it with mineral spirits and soap and got all the road grime off and stuff. And the factory epoxy on the floors were still in really good shape. So that came out nice. Got a couple little touch-ups where we cut some heat shields out. The truck bed still needs to be, we're going to have to paint that, but that's the picture. So it's got outer control arms, and it's got a third link in the center, and then a Panhard bar in the back. So it should be a really, really good ride. We went ahead and welded the tubes on the 10.5-inch rear end. We're going to stay with that. It's got 373 gears. It should be fine for the twin turbo motor. And so there's a picture. Obviously you can see this section is, and the firewall is what we need to have painted now. So that's where we're at with that. So that'll go down to the paint shop, and they'll do that in gloss black. He's already got the inner fenders. We're going to do them in gloss black, and then we'll be ready to start mounting the engine and transmission in that thing. So that was a good progress made. Now it can be rolled around the shop and stuff like that. So that was pretty much most of the stuff in this week. Now I guess we'll kind of get into the Holley stuff. Let's see. I want to start out with Mike's car. Mike says there's a torque arm bolt to the trans like a third member. No, it's actually got a torque arm. It's actually got a diagonal link that goes in the chassis. Let me I'll bring that picture up. Where is it? as you can see in this picture. So you really can't, I guess you can't see it, but right above, right, let me rotate this. There we go. Now I can enlarge it up a little bit. So this is your cross member under the bed where the gas tank would mount. So there's a diagonal link that goes from there to the passenger side frame rail, which then has a mount to grab the torque arm. So if you've messed with, remember the third gens like Doug's car, when the torque arm goes all the way to the front to the transmission, that becomes your instant center on the suspension. And if you guys remember, probably 30, 40 episodes back, we were talking about chassis setup. So when your IC, your instant center of your rear suspension, lays on the when it overlays the forgot the word of that, but there's a squat and a squat line. So with the stock Camaro torque arm style that goes all the way to the transmission, the IC is way forward of that anti-dive line. And so what happens with those cars is they squat really hard and they wheelie really easy, which isn't good. So the trick on the third and fourth gens is Spoon and a couple other companies make a shorter. I just thought another name popped in my head, but BMR. So they make a shorter torque length with a new cross member, and that moves the IC back and gets a lot of the squat out of the car, so the car will actually move forward. Whereas with the squat, with a lot of squat in the car, with the IC way forward, the car actually will squat and then leave and then go forward. So if you were in super slow-mo, you would see that you're actually slowing the reaction of the car down because you're using all the torque of the motor to crush the rear suspension before the car actually moves forward. Having the IC closer to that squat, anti-squat line, the body pitches much quicker and the car leaves the starting line much quicker. Now you can imagine on a truck with a much longer wheelbase, that would even be way worse of a situation. So they give you a new point. So the torque arm on this, I didn't measure it, but I think it might be 48 inches forward. So in that picture you could see it's basically going to put the IC right where the front edge of the bed is. So it should work out really well. I've seen some information from QA1 on cornering G-loads and stuff and traction with this kit, and it really works really well. So it's going to be, and of course, and we're going to be twin turbo this thing, so it needs to be able to have good traction. Whereas with the leaf springs, you got wheel hop, you got all the issues with the leaf springs and trying to hook tires up and stuff. So this is a far better way of doing it. So, so let's go back here to Mike's car. Let me see what I want to bring. I need to bring up the data log, and I want to bring up so one thing. I didn't get this stuff organized very well tonight. Sorry about that. It's been a very busy week. All right, so if you guys remember anything about last week, we were working on Mike's 66 Chevelle, trying to get the transmission to shift. This was we talked about this a little bit last week. This was the Holley transmission harness for the to operate that, and then we were talking about this deal here, which is something I came up with. where you could make a automatic transmission into a manual shift by using the pressure switch manifold to energize the shift solenoids. So we went ahead and did this with Mike's car, and we went out on Saturday and did some data logging, and I wanted to show you, this is kind of good stuff. So one thing we had an issue with, we knew the Holley would data log the output or the command to the 4L80, and this kind of teal line represents the shift position. So that's the command the transmission is sending. But our problem was we still didn't know what the transmission was doing. So one of the things I did was I went and I took 2 voltmeters and I back probed the J4 connector on the Holley, and with the ground side of the voltmeter, and then went to 12 volts. So now we could watch the 2 shift solenoids. So the way the 4L80 works is you ground the 1-2 solenoid, and that gives you first gear. Then second gear, neither solenoid has a ground. Then third gear, the 2-3 solenoid is grounded, the 1-2 is not. And then fourth, both solenoids are grounded. So we were able to drive the car around and watch the, I could have created a file and actually put the data in the Holley data log, but we were trying to do this quick and easy, and it was just easier for me to sit in the passenger seat and read the voltmeters. Unfortunately, it wasn't good for demonstration tonight, but anyway, let me go back to the data log. So here's our cursor line where we're at, 1200 RPMs, 3% throttle, in first gear, rolling about 17 mile an hour. The green line here is speed. So we can go back to here. Now we're, oh, I don't have speed on there, sorry. So there's speed. So we're actually driving down the road. So there, Mike puts it down in the first gear. You can see over here the transmission is looking at the pressure solenoid, pressure switch manifold, and that's telling the ECU what gear we're in. So we're in first gear because it sees pressure through the valve body. And then we're accelerating through, and you can kind of see on this gold line here, we're starting to go faster. And then we get up to here, and on right here, Mike shifts the car into second gear. But you don't see, on this red line, you don't see a drop because it didn't shift. Even though the computer commanded second gear, and I'm watching the valve body, I'm watching the voltmeters, and the voltmeters both went to 0, so, or not, they went open, so both shift solenoids were then open, but the car still did not shift. So then we continued on a little bit faster. He revved it up to almost 4,000 RPM. It still didn't shift. He finally pushes it in the third. The Holley sees the pressure switch modulator module shows that it's now in third gear. The voltmeters are now showing me 1-2 solenoid open, 2-3 solenoid grounded, commanding third gear. You can see by this red line here a significant drop in RPM. So it did make the shift. I can make that, maybe make that a little bit more pronounced for you. There. So you can see on the 1-2, it never shifted. Right here, we put the cursor right there. Right there's where he commanded to shift, and lo and behold, the engine shifts. The engine drops RPM, drops into the next gear, and it works. And then, of course, he was backing out of the throttle because we were going pretty quick. But if you go out here, where he shifts into fourth, boom, and the engine drops down again, and the The car is shifting and it's doing everything it's supposed to do except for second gear. The reason I did this and I wanted to show you guys, Mike not being a tuning guy, but he still trusted the Holley system. He was concerned that there was a software bug or an issue that was not allowing it to shift. Now, this transmission was built by a reputable racing transmission shop that it's a buddy of his, and they did go back through it on the first time we went through this and it didn't shift, and they really didn't find a problem with it. They put a new sprag in it. So on the 480 and a turbo 400, the sprag stops the drum from spinning, and that's what it stops one of the planetaries and that's what causes the second gear. First gear, both planetaries are going. Second gear, only one set of planetaries are going. So the sprag stops that drum from rotating, and that's what causes the car to then shift into the next gear and go. So talking to some of my buddies down here, they were like, that's good that they put a new thing in there, but sprags are finicky because you can only test them by hand. You can't, obviously the vehicle puts way more load on them than what you could do by hand, so it's really hard to tell. And of course, my buddy Jonathan, he's been a transmission builder for over 30 years and worked in a bunch of GM dealers, so he knows the GM units in really good. Builds tremendous, very good 400s and 480s and power glides and stuff for racing, high horsepower stuff. And one thing he has ran into that I didn't even know is that he's seen where the race on the drum will actually look perfect, but it'll be undersized. And so the sprag doesn't have a lot, it doesn't take up for a lot of space. So if the race is undersized, there's a good possibility the sprag won't grab. It might grab by hand, but not enough pressure to make it grab in the vehicle. So we gave the Mike's training guy a call, told him what we encountered, what we did, and he kind of agreed. It definitely sounds like there's something going on inside the transmission. That's when he had said that he only tried to sprag by hand. And then he did say he has seen on some of these 3,000 and 4,000 horsepower turbo 400s. This guy actually builds some units for some of the NPK King guys. He's actually seen the race come loose in the drum, the race that the sprag runs on, and actually spin in the drum. So, we talked, and he was like, I'm just going to go ahead and put a complete new drum and new sprag in this thing, and that should get us fixed. But so that's good. Mike should have his car all straightened out, and the big thing for us is that we use the data log to show and to help in diagnostics that we are able to see what's going on. One of the things that my buddy Jonathan was saying, is there an OBD2 port where we can scan it like an OEM? Because the OEM would have a lot more information there. And obviously, aftermarket stuff doesn't go in depth into that kind of stuff. So, but using the voltmeters, we were able to make our own pattern. And, that may be something I may go ahead and wire up in my car, because I could easily come off the outputs with a wire going back to an input, and then I'd be able to monitor what the, if the commands are actually going to the solenoid. So just kind of a thing there. I just wanted to show you how we use the data log to help diagnose. In this case, we could have been round and round in circles with thinking is in the software and the computer, changing tunes and files, and it would have been all for nothing. So I just wanted to go over that, show you guys how you could do that. So let's go. I had another similar diagnosing tuning job last week. So let me go back to the tune. So this is another friend, Norman. He's got a I don't know what year Corvette he's got. 69, 70 Corvette. It's got a 383 with Hillborn injection, but it's electronic fuel injected. And he put a fresh engine in the car, and he was telling me, that he had this weird hiccup situation going on. It just arose after he put the new motor in. So we went through the tables. I looked at the Target AFRs. They looked good. I went to the. I didn't get it tuned. I didn't use a tower for the tuning, so I don't have the learn session in here. But everything was pretty good. There was a fuel graph in here. Okay, that one was already smooth. All right, so let's go to the data log. So we go for a ride in this car, and sure enough, it's got some anomalations here. I really didn't notice anything here, but here we're 1600 RPMs. We don't have speed because it's a manual transmission, but it was off the target a little bit. Blue line here, kind of hard to see that blue line, but that blue line is the target AFR. Let me switch the screen to white, see if that's any better. Well, we'll switch back and forth because it's better for the fuel. So here's our target AFR line, and this green is the where we're actually driving. So let's go back to the black screen. Why didn't it go back? All right. I don't know why I did that. All right, so that's a little better anyway. So there's our dark blue. The yellow is our our actual AFR. So the blue is where it's supposed to be. The yellow is where we actually are. And so he gets in this RPM range of between let's see here, he's 1700 RPM all the way down to 800 RPM, 1700 RPM. So he's kind of easing on the throttle while we're driving down the road, and the thing just starts surging and almost sounding like it's shutting off. But what it actually was is the injectors were almost turning off because it was going so lean. And this one almost got me. I almost started going after tuning the map, but I couldn't understand what was going on here. So I started looking at some of the data. Do I have sensors on this one? No. But I'll show you what I found. Put TPS on there, and you see when I put TPS on there, there's no line. And if you look at where the target is, right there, let's go right here, it's 0. So no matter where we were on the map, there, over here, TPS is 0. So I immediately told him, pull off to the side of the road. And we pulled over, and lo and behold, the screws had backed off the TPS, and the TPS was just dangling on the fuel injection. So that's what was going on. Is the engine has RPM. It has we go back here, I didn't show that. Up here is the red, that is load. So it has load on it. Even though it's an individual throttle body, it still was showing a vacuum signal. If you go like in here, you can see, let me switch this back to white again. You can see here there's dips in the red. Those are load positions. So the load was changing, RPM was changing, but the computer still saw that it was in idle circuit. Anything under 1% TPS is idle. So at that point, you got idle compensation, timing compensation coming in. So it's jacking the timing around and doing a bunch of crazy things. So I just kind of snugged it down. We limped it back to the house. I reset TPS, and we drove the car around, and it was perfect. So again, one of the things that, here he thought that something happened to the tune. It got corrupt, had maybe a bad injector or a vacuum leak. He wasn't sure what was going on, but rather than, luckily, rather than going into it on his own, he brought it over and I took a look at it. And like I said, we figured it out. Luckily, I didn't have to spend a lot of time on it. It came up pretty quick, but it just goes to show when you are doing tuning how critical it is to make data logs so that you can hunt for anomalies. Now, I didn't see the TPS at first, but before I dove in and decided to start changing stuff, I started going PID by PID, sensor by sensor, to see what was going on. And in my laptop, I have a data log section with just all sensors, so that I can see all sensors on one screen together: oil pressure, fuel pressure, and all those RPM, TPS, map. And that way, I'm not worried about AFRs and all that. I just want to make sure we're getting good information relayed to the ECU, so the ECU can then make its fuel and timing calculations. And when I did that, I saw no TPS. So just for you guys that might not be doing any tuning or may possibly going to start doing some tuning, like you're going to put a sniper on your car or something like that, the importance of data logging. When I'm talking to people and I'm giving them the variations of what each Holley system does, the snipers and the Terminator, Terminator X, Terminator X Max, all have to data log through the SD card. So you have to have your screen in the car. It's got to be hooked up, and you have to actually activate the logging portion, and it'll send the log to the SD card. And then you can take that out and put it in your laptop and decipher what's going on. You cannot see the data log on your handheld. Now on the HP and the Dominator, obviously they do internal data logging, so you can just set up immediate data log, or you can set it up with parameters by TPS or by RPM or whatever you want to set, and then you can go back and refer to those. Again, you have to upload those to the laptop to actually be able to use the software to diagnose what's going on. But just the importance, most of us have messed with carburetors, and I've shown in the past how you can break down the fuel maps and stuff on the fuel injection to simulate what it would do if it was a carburetor. That's how I started my tuning career, and it's a real easy way for me to explain and to show people how they can get into tuning themselves. As you think about the car running, and you're like, okay, if this was a carburetor, I need to put more pump jet in it. So then you can go to acceleration enrichment in the ECU, and it will do the same changes if it was a carburetor in the pump jet, or if it's EFI with the acceleration enrichment. And your base fuel map is basically all the main circuits of the carburetor: idle circuit, mid-range, power valve, main jet. So as long as you take that information and go back to what a carburetor would do, it kind of makes it simplifies the whole tuning situation. But you still might not be thinking about using data logging. So that's why I wanted to show you guys this, because that just puts another layer of information on what you can translate what you think the car would need if it had a carburetor. But now you can put the data log, look at the data log, and actually see what's going on, and just help you to make better choices and better selection on what's going on. Another one that we were working on. Let me pull this one up. This one, the guy was up at Run the Sun up in Myrtle Beach. So obviously I wasn't there tuning his truck, but he was up there driving around, and he gave his buddy a call, who gave me a call, and we went through, fixed up his tune while he was there. So first I want to show you a data log that we have on it. So that's not the right vehicle. 1 second, get the right tune. Okay. So this is a sniper truck. It's got a sniper on it, and it's got a dry shot of nitrous on it. And so he went to the drag strip and he made a pass with it. So the data log he made was, pits, burnout, the whole thing. So we just want to see the portion where it was going down a quarter mile. Fine tune this a little bit so we see it. Okay. So what we have here, we have green is the TPS. Yellow is that's the closed loop compensation. Red is the engine RPM. Purple is actual AFR. And the blue is the map sensor. We don't need the map sensor, so let's get that off. But let's put target AFR up. So there's our target AFR. So you can see the tune is pretty decent on this thing. And so we were concerned with this because the truck makes a fair amount of horsepower. And do I have duty cycle? Yes. Yep. So the truck makes a fair amount of horsepower, and we're using a dry shot. So all the fuel that feeds the engine, for the engine wise and for the nitrous, is going through the injectors of the Holley Sniper. Now, the Holley Sniper has 4 100-pound injectors, so it's good for 650-ish horsepower, all depending on the efficiency of the engine. So what we can see here is, put the cursor back here. So here he's at 1900 RPMs, 7% throttle. I don't think the truck has a, let's get this closed loop. We don't need the closed loop comp on it. I don't think he's got a trans brake. I think he was just power braking it. So tree goes on. Let's see, we don't have nitrous on this one. Let me switch tunes here where we get the one with nitrous tuning. So we have nitrous also. Stage 1, base fuel. We don't need base fuel pounds. Fuel flow, we're good there. We have target and actual. Okay, we're good there. This one does not have duty cycle. So let's add duty cycle real quick. So we go into editor, go to nitrous. Let's get rid of real time, and we want to put duty cycle of the injectors, because our concern was if we're running out of injector while the nitrous is on. Well, I didn't drop it in the right spot. Where was it? Okay. All right, so this purple up here, good, this is a much better color. This purple is the injection, fuel injector duty cycle. So here he's on the starting line, takes off, stomps the throttle. This teal line here is the nitrous coming on. Now it's got a progressive controller on it in the Sniper. That's the beauty of all the Holley products. They've got progressive controllers built into the software. So we got that progressive going, but it's a pretty steep ramp. And right here, it tries to spin the tires, and so he kind of pedals the throttle a little bit, catches the tires, and keeps going, and the nitrous keeps engaging. But you can see at our duty cycle down here, 101 duty cycle, so we are out of injector. And you can see the motor's a little lean right there. And as we go through, kind of stays right about that same point, but the AFRs are a lot better. And then out here, you'll see you see the red line right there. Let's go back here to that point. There, the motor hits 6,900. So at that point, what that is when it shifted into 2.3, the transmission flared on the shift. So the transmission may need a little bit of cushion there, which then it over revved, and there's a RPM safety on the nitrous, so it shut the nitrous off. And then once the transmission shifted, then the nitrous turned back on, and the progressive controller ramp came back in. So just kind of showing you how much information you can get on here. Now, what we're going to do with this thing would be to remove the in-throttle body. The Sniper comes with a 58 to 60 PSI regulator built into the output of the Sniper to return. So what we would do is remove that and have the Sniper fuel flow straight through the Sniper and put a mechanical fuel pressure regulator on the firewall, and then manually increase fuel pressure, say 75 psi. That will open up the pound per hour of the fuel flow of the injector, and then bring that that duty cycle back into under, I'd like to see it like under 95%. Then we know we have a good safe tune, and there's 5% correction buffer in the tune. So again, a good use of the data logger. The truck made a good killer run down the track, made a personal best. Plugs look great. If you look at the plugs and stuff, you wouldn't know that there is the possibility of a major error coming. With the injectors already hitting 100%, it's not terrible, but the problem is now you have no more cushion room if the barometric pressure, the weather conditions changed. Drag racing and engine tuning, we always worry about density altitude. So what density altitude is your track, or your wherever you're at, is you have an altitude above sea level. Here in Florida, we're about 15 to 30 feet above sea level. But barometric pressures, humidity, dew points, wet bulb, all those come into factor, temperature, and what racers use for tuning is, we call it density altitude. So what that is the altitude, the density of the altitude that has all the weather and all those other things combined. So when the weather's really bad, you can be in a density altitude of 2,000 feet, but you're still only at 30 feet above sea level. So in that situation, the fuel injection is going to want to make an adjustment, because it's going to need to add more fuel to the tune. So if you're running your injectors at 100% already, you're not going to have that available to you, and you have the capabilities now of burning the engine up when the night before it ran perfect. So again, use the data log for that information so that you can find out if there needs to be changes made. Just awesome tool to have at your disposal, and it comes in all the Holley systems, all the way down to your inexpensive sniper. Now, getting back to this truck, we'll go back to his tune, and let's see. I think I have to get rid of. I want to get rid of the colors. All right, why not used to the oh, anyway. So we pull up the fuel graph. You can see in the center here, there's a pretty big bump in there. And the reason that is, normally you want your you can put in a conversion. It's not as exaggerated in pounds per hour, but in VE, it's a pretty crazy looking hump. So what happened was they took the truck to run the sun, and he's cruising up and down the highway, and he said the more they drove it, cruising wise, see, it started really running pretty terrible. So what I've found in past experience is when you have a camshaft that's got a lot of overlap in it, you can actually, when you have a lot of overlap, what will happen is, with the closed loop in learning, so on the Holley system, kind of like a OEM, your closed loop parameters is your short-term fuel trimming. So that's what I call a knee-jerk reaction. The computer sees the motor's lean, it makes a quick adjustment to that cell. It sees the motor's rich, it makes a quick adjustment to that cell. It doesn't record that correction, it just makes it right now. And then when you move away from the cell, it goes back to the original base tune. Now your learning parameters, just like in a OEM computer, which would be your long-term trim. So what long-term trim or learning does is it watches closed loop or short-term trim. And it says, hey, whenever you're on this cell, you're always adding. So let's go ahead and just learn and add a percentage to that cell so you don't have to work so hard closed loop. And that's how that all works. So the closed loop is a real quick, not recording deal. And then the learning watches it and says, hey, you're always skewing lean. You're always skewing rich on these cells. Let me go ahead and make a correction in the learn table over top of the base table, and that will make it so the closed loop, the whole idea is to have the least amount of adjustment. So what I have found on roots blower cars, and on cars with a lot of overlap, or cars with large exhaust and maybe short exhaust, is when the overlap of the cam or pressure surge of the blower is, you get dirty signals in an exhaust pipe. So now you may have tuned it on your base fuel map where it needed to be, but now you're driving on different load positions, but it's still in that same area on the fuel map, but different surrounding conditions. And so now the closed loop and the learn are trying to fix it, but it really doesn't need to be fixed. It's an anomaly. It's a dirty signal. So what I did on this tune, you can see here in this lower section, 0 to 105 kPa, which would be 30 inches of vacuum to 0 vacuum, and from 0 RPM to 2000, I limited the closed loop parameter to 15%. And then I go into learn, and I told it 0 learn. I don't want it learning anything. because we know because of the camshaft and the exhaust and whatever of this engine combination, we're getting a dirty signal there. So we've already tuned this thing on the base map. The base map is already tuned. We don't need to worry about that. So now it's a condition that's worsened as the car has been driven. So this is where we turn off the learn in that spot, and it can use the closed loop as a quick fix, but it's not going to learn anything. So it's not going to use that quick fix and start changing the base fuel map to do something that's wrong. We already know our base fuel map is correct. So that's what I did. We sent them the file back and installed the tune. And the rest of the weekend, he said the truck drove like $1 million. So again, using your data log and stuff like that, you can come up with this stuff and just helps aid to making you a tuner or a better tuner with minimal amount of experience. It works really well. And the nice thing about all this stuff, when you're in a carburetor, you're in the car seat of pants. You might have a vacuum gauge on the car. You might have a wideband, but there's no recording, so you can't take your information and go talk to somebody and say, "Hey, what do you think I should do here? I'm making adjustments, but it may not be working, or it is working, or whatever." The beauty of EFI is you can take your tune file and your data log file and send it to somebody like myself or any other tuners, or even guys that are just helping out, and we can together go over these files and all learn new tricks and new things that we may not have been aware of before, and just makes it so much easier to get your vehicle running properly and all those fun things. So just thought it was a good thing where these are actual situations that I've ran into in the last 2 weeks, and I just thought it would be a good case study so you guys could see how I used the information and then made corrections and then solved the problem. So that's basically all we are trying to do, and everything in this whole hot rodding or even life is problem solving. That's what we're trying to do. So anytime we can get more tools in our arsenal to do troubleshooting or fixing these problem solving, the better our lives get, the better our hot rods get, better everything gets. So just thought that was good information for y'all. I hope you enjoyed it. Hopefully I'm going to have the dash back in the Chevelle so I can get you guys a good walk around video on the Chevelle. We need to get officer in to do a VIN verification to get the title straightened out so we can get a tag on the car, and then we can start doing some cruising, and we'll get some data logging on it also. And also I didn't have data logging, but I used data logging on that car too. When we first got it running, we were taking it to the body shop. It had a pretty big flat spot in it. But for me, tuning with base fuel consumption, I can pretty much write a tune. It'll be fairly good by just making the fuel consumption numbers matching the horsepower that the engine puts out. So if you know how much horsepower a motor needs, it's pretty easy to put the proper amount of fuel in it, and then all you have to do is just clean up the curves, so to speak. Where it goes from vacuum, low RPM, to no vacuum, high RPM, and stuff like that. But usually you can find that within 10%. So with it having that heavy flat spot, rather than going in there and start chasing the tune, I looked at the data, and sure enough, it only had 25 pounds of fuel pressure, but the car is supposed to have 60. So we went ahead and took it to the body shop. It started up and idled fine. You couldn't drive it, but it didn't have tags or insurance, so you couldn't drive it anyway. So when it came back, I had a new pressure regulator for it. Sure enough, the diaphragm was ripped. The other thing that cued me in on that was excessive cranking. I could look on the 3.5-inch screen, turn the key on and there's zero fuel pressure, and I'm cranking and the fuel pressure is slowly building up. Well, the reason for that is the regulator and the return is at the gas tank, and then you have a single line going to the front of the car, up to the fuel rails, and filling the fuel rails. And all of that is elevated above where the pressure regulator is at the top of the tank. So what was happening was, being that the fuel pressure was losing, I said one of two things. Either it has a rip diaphragm, or the check valve in the fuel pump is no good and the fuel is all running back to the tank. Now when you take the fuel running back to the tank and low fuel pressure when the engine's running, that told me more than likely 99% chance the diaphragm in the fuel pump fuel pressure regulator was bad. So sure enough, put a new regulator in it, turn the key on, immediately 60 pounds of fuel pressure, and I'm monitoring fuel pressure at the fuel rail. So it's at the last part of the vehicle to get fuel pressure. Now the car rotates over maybe 3 times and fires right off, and there's no flat spot. I also used the data log by looking at the IAC. Now, if you guys remember our first drive out, Cars Alive videos, we had 2 shorts that I had made on it, and when Chuck pulled up to me holding the camera, you could hear a loud whistling noise coming out from under the hood, which is typical of IAC being open. Well, I could go to the data and see that I had the IAC adjusted correctly at idle. It was 0. So that told me this engine actually has a dual throttle body sniper manifold on it. And the second throttle body, I have a IAC delete block off plate in the throttle body. So again, being we were taking it to the body shop, I just sent it the way it was, let it whistle, it's okay. When it came back, I started doing some research on the block off, and what I ended up doing is putting Dykem on the block off, pulling off the sealing O-ring and sticking the block off in the throttle body and twisting it around to get a witness mark. And so then I was able to pull it out, and I could see that the button that closes off the IAC did not have anything disturbed on the Dykem, so no witness mark, so it wasn't sealing. And I could see that it was a step farther out, and all the Dykem was going on there, so it was a machining issue where they machined either the throttle body or the step on the piece and left a burr or something. I just took a small file, kind of put a bevel on that, Dykemed it again, stuck it back in, and it took 2 times. On the 3rd time, I got a clear witness mark on the end of the button where it seals off the IAC passageway. Put it back together. Now the car idles dead quiet in the front, no IAC control, no IAC error noise from it. So now you can just hear the engine rumbling. You don't have this loud whistling noise going on. So just another case of, use all your data that you can get so that you can see what's going on, and it'll help in rather than pulling your hair out or chasing things and not knowing what's going on, so good data. I always tell people data is king, and you'll see in future episodes when we get to the VetHawk that I'm using a Dominator ECU, because that ECU will take 40 inputs and 40 outputs, and I'm planning on using a lot of them. So we're going to have all kinds of sensors on the car, because I'm kind of 50% or decent at a lot of things. I'm okay at chassis setup. I'm okay at tuning. I'm okay at shock settings and stuff like that. Track mapping. I'm not great, but the more information you can put in front of you, the better you can make decisions, because you can make adjustments and then do another test and see if it worked better or not. So that's pretty much it. I know I wanted to show you guys. I forgot. Sorry. I wanted to show you guys the alignment sheet on the truck. Let me just find that real quick. I said in the video I did a garage driveway alignment, So I just wanted to show you this. Okay. So yeah, so here's the alignment sheet, and up here the top half is how the vehicle was aligned when I got there, the initial. So you can see I had a 3.3 degrees of positive camber on the left front, 3.5 on the right front, 1 degree positive on the left front, and minus 0.3 on the right. And of course the toe was set. I used a toe plate for there. So just using eyeballed him and put a level on. I just kind of stood back and looked at it. And what I did was on the eccentrics, I kind of put a lot of I moved the eccentric so that the rear of the upper arm was back and the front arm was out. So that moves the upper ball joint towards the back of the car, which, like we were talking about a couple, when we were doing the chassis sections, is you look at your ball joint inclination, top ball joint to bottom ball joint, you draw an invisible line. It's like a fork on a bike. So the more that angles back, the more positive caster you have. So it worked out real well. I just had to make a couple simple adjustments, and I ended up with 4.2 on both sides for caster, 0.3 positive for camber, and it actually shows 0 degrees of toe, but it's actually 1/8 inch towed in. The alignment machine was set up on degrees and not inches for toe, and it's really sensitive. So when I tightened the bolts, they were at 0.05 on both sides, and just tightening the nuts, it turned that. I went ahead and fixed it afterwards. So, but just wanted to show you, you can do an alignment in your driveway. If I had to put a level on there, I would have probably had it pretty darn close to spot on. So sometimes you can use other tools to do a job that you don't have to have a big fancy $20,000 alignment machine to get the alignment close. Where I had it, it would have drove down the road. Well, it did drive. I had to drive 20 miles to the machine. Drove fine. Steering wheel was a little crooked because I didn't have it centered, but other than that, it drove good, and it could have driven like that for a while and not wore the tires. So, but now it's spot on, and we should be in good shape for our Darlington trip. So, again, can't wait for that. We'll hopefully have a bunch of cool video when we get back on not next Tuesday, but the Tuesday after, which will be the 9th, I think. So we'll have some video, in-car video going around Darlington in the Cup car, and we're going to be in the fan zone. So we'll mingle with fans. We're going to have the Stock Car Classics Facebook club. That's where I'm part of that, and that's we're doing the supplying the throwback for the racetrack. So yeah, I got to show the driveway alignment. It's not hard, man. We can do your car for sure, and then we can also go up to Doug's and put a machine alignment on it too. But yeah, I can go over because it's always good to be able to do these driveway alignments. When I was racing stock cars, we did those all the time. You might bang wheels with another car. You might rub the wall with a wheel, and between the heat race and the feature, you don't have an alignment machine. You gotta just use a level and string and maybe a laser if you're really high tech, and fix it before the feature. So, but yeah, so we're gonna get Stock Car Classics Facebook club. We're putting on the vintage display for Darlington for their throwback weekend, and then we're gonna do laps on the track at the conclusion of the Xfinity race Saturday night. So that'll be really cool. Hopefully we might get some television coverage on it. We have 25 cars that are going to be there on display. So should be a really good time. And I can't wait to, take the Cup car around the track that it raced there at one time in its life. I guarantee it. So big things, cool things. So anyway, next week we should have some stuff on Dave's car. Hopefully I'll have all the I'll grab some time to get all the wiring testing done, and I'll get some show you some videos and stuff on, or at least pictures of the teardown on Scott's Olnick race car hauler with the engine transmission swap. 366 tall deck, industrial engine and Fuller big heavy duty 5-speed transmission coming out, and the 8100 Landis performance motor going in with the Allison 1000 automatic behind it. It's going to make that truck a dream to drive. Should have about 150 horsepower gain and probably about 300 foot-pounds of torque gain, plus an automatic transmission. So can't wait to get that done. Hopefully we'll be using that truck. It's got to get some body work done. Hopefully the body shop can get it done so we can use it for LS Fest in September. So that's about all we got for tonight. Thanks for watching. Hope even if you're not doing any EFI stuff right now, you could see how we use data for diagnostics. And if you do get into some EFI stuff down the road, you can go back and revisit this and help you if you have a situation you want to try to figure out and see how I did it. So y'all have a good evening. I got my screen's locked. Anyway, you guys have a good night, and we'll see y'all next week. And I'll try to get this music back on. There we go. Almost there. Wow. Totally lost where I was at. Almost there. There we go. All right, guys. Have a good week. See ya.